So what are they doing, the researchers doing? Well, the issues are in naming and addressing. When you have these thousands and billions, actually trillions of devices, how do you address them, name them? And in fact, so some of the people are doing research on it. One of the very high-profile research funding from NSF was given to one group which was doing the naming. Service orchestration is that how do you basically do orchestration means doing multiple times, right? So if you have millions of devices, how do you put one command and control them? That is orchestration. Power efficient communication. So then you have to worry about, how do we minimize the energy? Energy harvesting. How do we generate the energy to use? Things to cloud. So how do you send information to the cloud? Miniaturization is another research issue. How do you make things smaller? So there are sensors which are small, very small. There are transmitters which are very small. Big data analytics. Of course, big data is very famous now, and all of you know. Semantic technologies. Information and data models for interoperability. So now if a thermostat is generating something, the light is generating some data, and then something else is generating some data, how do we combine all of these? We have to have some semantics. We have to have some organization. We have to have some ways of saying this is what it is. This is the temperature. This is the light level. This is time, and so on and so forth. So all of that has to be standardized. Virtualization. To make one out of many and to make many out of one is virtualization. Privacy, security, anonymity. There's a lot of whole security work to be done. And heterogeneity and scale. Basically, things that we could do on a small scale, now we need to be able to do on a very large scale. Things that just one kind of technology, now we have to be able to do on different technology. Things that are static, we need to be able to do on dynamics. So there's a lot of work, and everybody is actually working. Now I'm going to go into the next 4 slides about what's happening, trends, and then take to our research, like how we are working on this. We are very much deep into this, and then we move on to the wireless. So one thing that is happening is that, and actually that happened past. One thing that happened in the past is that when we started doing internet and started getting data, we found that if the data is verified, we have to go to the server every time, the response is very slow. And therefore, they figured it out that we should make many copies of the data and keep it close to the users, those copies, so the users can get it right away. And this is called CDN, Content Distribution Network. CDN. CDN is Content Distribution Network. Basically, so there is a company called, what is the name of the company? I forgot. But basically, the company makes money by simply taking your data and putting it at 15 places in the world. Okay? It's an IT professor company. Basically, so the idea is that if you keep many copies everywhere, then people can get it right away. So if you're in China, you don't have to come to USA to get the data. It is right there in China. And in fact, China is a big country, so it might be at many places in China available to you. So that is called data in the edge. So everywhere the data was brought close to the user. These are storage devices which were brought close to the user. Well, so now the storage is not the key. The key is the computation. So if we want to do something, nowadays we are not just looking for the data, we are looking for getting something done. Let's say you are doing Siri and you tell your phone, okay, tell me what is, this and that, right? It has to digitize that voice. It has to interpret that voice and then look up and give you the answer. So looking up is a very small part of it, but there is a lot of computation before that part, right? That part has to be done in the cloud. And therefore, we need to bring the cloud next to you. Right? So the phone companies are working on what they call mobile edge computing, MEC. Mobile edge computing is the idea that all the towers will not just have the radio, but they will have a cloud, micro cloud on the tower. So when you say something to Siri, it goes to the micro cloud and comes back. It doesn't have to go to California to Apple's headquarters. Okay? And micro cloud even might have some piece of Google in it, which basically it can give some common answer for recently asked questions, right there. And for some things, you have to go to Google's cloud. So this is called mobile edge computing, also called fog computing. So the fog computing means computing everywhere. Okay? So when the clouds come down to the ground, we call it fog. Right? And so that is what fog computing is, that computing everywhere. It's not just in the cloud, but the clouds are everywhere. So on just one cloud, there will be lots of clouds. So that brings us to multi-cloud. Basically, whenever you have an application, it will not be just on one cloud, it will be on multiple clouds. It could be here, 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 here. There could be local cloud, there could be regional cloud. And so we are working on that. So we have a PhD thesis, which allows you to do this. Is basically you can develop an application. So for application development, we have some interfaces. And then after the application is developed, you tell it to our platform that I want to deploy it, and these are the different kinds of clouds that I need. These are the different resources I need. And then it has these interfaces to different clouds. So it has interface to OpenStack, it has interface to Amazon, it has interface to the network management system called OpenDaylight. And then basically, once you have told it, then it can automatically do the rest of it. So whenever users come on and it needs something, it will create a new VM in the right cloud. When the users go away, it will remove the VM from the cloud. So this is called management, application management. And the clouds could be anywhere in the world. They could be in different countries. They could be owned by different companies. Some could be Google, some could be Amazon, some could be IBM, Microsoft, with different interfaces. So that's our research. And then anybody, most of the people who are working, actually I see only 4 or 5 people here who are working on this, they have already seen all of this. And one application is, for example, this healthcare application. So this application basically requires some people to wear something on the body. And whenever the sensor says that something abnormal has happened, it tells the local cloud. And the local cloud has some part of that application which decides that this is really serious stuff. We have to call the doctor. The doctor is on a different cloud. And it has to call the hospital and the insurance company. All the information is done, and then basically the connection is made, right? So as you can see, there are at least 1, 2, 3, 4 clouds involved here, and could be even more. All of this, it can be done without any manual intervention. It is all programmed. Okay, and of course, we'll have to find out the closest cloud for the hospital, closest cloud for the insurance company, because those may not be just one cloud. There could be many clouds, right? Similarly, the closest cloud for the doctor, and so on. So this placement of these services is clearly an application, right? So that's what we're working on. But anyway, back to IoT. So IoT is a big deal, big money, both for researchers as well as for businesses. And but there have been lots of protocols on IoT. There have been lots of protocols for IoT in the past, but they are all not standard in the sense that every little corner has its own protocol. So building automation people, they are using .NET. Other people who are using Loanworks, some other manufacturing guys or whatever, they're using Modbus, KNX, Z-Wave. There are lots of these. And so mostly, not so much in the home, but mostly in the industries, except for the BACnet, which was not used in the home, but was used in the enterprises. For example, our buildings here probably had a BACnet controlling the controlling the heat and cooling in different buildings. Okay, so there are lots of protocols, but now we really need a standard, right? So there is a standard. Basically, there are lots of standards. Okay, and so this is a list of some of these standards. And what is happening right now is there is no one standard. Every standard body is developing its own standard and hoping that they will be the leader. Okay? And so basically right now, just for the data link, there are many standards. For the network layer, there are two different sub-layers, encapsulation and routing. How do you get the message from A to B is routing. And how do you encapsulate a packet into these tiny packets, because IoT packets are tiny, but your message may be large. So how do you encapsulate it? That there is a whole set of protocols for that. And how do you do the applications on the top of it? There is a whole set of application protocols for that. For security, there is a whole set of applications and management protocols. We will not talk about most of these except for the data link. And even in the data link, we'll just talk about the wireless data links in this course. In the other protocols actually are covered in my other course. So these protocols, some of these protocols were covered in the previous semester at recent advances in networking. The security will be covered in some other semester when I teach security course. But in this course, we will not do security. And we will not do the other parts because those are, but in these other courses, we didn't discuss the wireless. So in this course, we will take this wireless component of IoT. Okay? And what I have done here is try to indicate in bold those protocols that we will try to cover, hopefully. And the ones that are not in bold, either they are very similar to the other protocol. For example, WiMAX is similar to LTE, and HomePlug is not a wireless protocol. So we'll try to cover as many wireless as we can. Okay? So the next few modules will be on IoT. So far as the standardization is concerned, every standards body is working on it, and there are several new standards bodies that have come up just for the IoT. So IEEE is working on 11.15.4 HomePlug. Zigbee is working on Zigbee Smart. Bluetooth is working on Bluetooth Smart. IETF is working on RTL. ITU is working on many of them. HC is working on DECT, and so on and so forth. And then 7 organizations added ATIS, CCA, and you can just look up their thing. They have combined together to form one organization called 1M2M. So here are what is machine to machine. This is what is machine to machine and device to device, IoT. Okay? So this 1M2M is one organization which is trying to develop the whole framework for machine to machine communication. Okay? I think I will stop right there and complete it next time.